Hello everyone, so today we are going to do Leetcode daily challenge, increasing order search tree. So in this question we are given with the binary search tree and we are required to simply convert into a tree which is in increasing and it is in order and it is a search tree, which simply means that everything is in order and it is in the increasing manner only. So as we are given with a binary search tree, right? So because of this binary search tree only, we could use the property of binary search tree and we could easily convert this particular into an increasing order search tree. So let me explain you how we can do so. So we are given like this and we need to convert in this manner. So as it is a binary search tree, right? So what we can do is we can simply use this particular property, that is left less than root less than right. Right? So how we can do this? So what we can do is we can simply go towards the end of the leaf node of the left subtree. If left subtree is not given to us, then also what we can do is we will be going towards left side, right, but it won't go because it is null, right? So it will simply go towards this particular portion, but at that moment what it will be doing is it will simply have this particular, because this would be the one which would be having the smallest value and it would be stored, and then it will go towards the right, and after going towards right it will check for its left, and if left would have some value, then it will store the left value and then it will go towards this position. So like this it will be storing out, means all the process would be in this manner only, and how it will be going ahead and storing the answer would be in the in order by simply doing the in order traversal. And in order traversal what we do is first we simply traverse towards the left side of the tree and then we'll store the answer, we'll do some processing, and then we will be simply going towards the right side of the tree. So this is all what we would be doing in our in order traversal. So for this particular fact, this is what we would be doing. We will simply go to the leaf node of the left subtree. Meanwhile, make new skewed tree. This is basically a skewed tree in which we don't have any left node, right? We have just right children only. And then what we are doing is, which has the present leaf node, and then take the mid root to the answer. So what all we are doing is we are simply going towards the left subtree, and then whatever was at the leftmost, then we are taking that, and whatever was there, the root of that left node, then we are simply taking that root node also in our answer, and then we are going towards the right side of that particular tree. Means if it would be at this particular level, then it will check for its left and then it will check for its right. When it will check that this is the leaf node, it don't have any left, then first it will simply do left null. At the first moment doing left roots null, roots left equals to null won't make any sense, but still because of this fact only, when we will be simply moving towards its parent, then we would be required to simply make it as null. So when we'll make it as null, then it will make sense, right? But doing roots left equals to null at this particular position, it simply turns out to be that we are simply eradicating the leftmost part of this particular node which we have taken, and then at this particular level only we would be simply checking for its right node, because we are having a binary search tree in which we are having nodes in this order, means left, root, and then right. So that's why what we would be doing is we will simply going in this particular manner and storing everything in this particular manner. So for storing everything in this particular manner, we simply need to check that how we would be traversing inside this particular tree, and when we know that particular fact, so because of that only we would be easily able to traverse. Basically we are required to check that how everything would be ongoing, then only we would be able to code it. So the thing is, first thing we need is whatever function we are having, we'll simply do root left. And we'll do this root left until root left becomes null. Basically, when root is present, means if root is there, then only we would be doing roots left, right? So when we'll do root left, so it will reach at this particular position, but when it will go more ahead, then it is null, right? So our root will be simply this particular position. It means it will reach the leftmost leaf node of our tree. This would be the first thing we would be doing. And then next what we would be doing is we would be having some dummy node, we can say, and in that node we would be simply storing our present root. Basically, if we take it as current, then we will simply do current equals to root. But before doing this current equals root is directly assigning to it, we are first required to do, means basically directly assigning to it, we are first required to do roots left equals to null. So while we would be doing roots left equals to null, so we would be easily able to get this particular portion, right? And then we would be simply assigning current equals current right, because at present current left is null because of this particular thing, and then current right equals to our present root node, that is this particular node 1, and then we will simply do current equals to root. That is, now our current has simply moved towards the root, means now our current is simply pointing at this particular position. Earlier current was simply equals to 0, means value was 0, and it was a dummy pointer at that particular point, means dummy node which was pointing towards null. But now it has some value 1, and its left pointer is null, and its right pointer is still not having any value. And then we will be simply moving towards roots right. This is what we would be doing at this particular moment. So it will check for its right, which is already null, right? So as it will go towards the right, so it will check that it is null, so it will simply get back towards this, means it will simply return to its previous one, and then its previous one will simply return to its previous one. These all steps which it is doing, it is all doing in the backtracking step only. So that's why it is simply returning towards its previous parent which was there, and then it is simply performing all those functions which were left at that particular time. Basically, it is unwinding the stack, because the thing was that first when it was here at 5, then 5 was pushed, then 3 was pushed, and then 2 was pushed, and then 1 was pushed. As it has some null value after this because it was a loop, then it simply popped out, right? So it simply checked for its left and right, and they were already null, so nothing was pushed into the stack, and then that's why stack simply was popped out at this particular moment. And then 2 was there at the top of the stack, and 2 was simply popped out, and then it checked for its left and right, both were null because this particular was already processed, so it was not processed again. Thus it was popped out again, right? And then after that there was 3. This 3, now it has been eradicated and processed. Now there was 3. Now at this moment 3 was simply popped out of this particular stack. Was popped out of the stack, right? So when it was popped out, it will check for its left, which was already processed, and it will check for its right. When it checked for its right, then it got this 4. So because of this, now 4 is simply pushed to the stack. And when 4 is simply pushed to the stack, now 4 is also popped out of the stack and will check for its left and right. like this only the things will happen in this particular question, and the things will go on. And this is how, when we know that when which particular node is basically popped out and pushed into the stack and how it is being processed, then it would be easy for us to simply store all those nodes and then go ahead with processing of those nodes. So this was all explanation about this question, and that's how things are ongoing. So now let us go towards that how we would code in this particular question. So for this question, how I've coded, we are having two functions. One is this main function, the main function which was given to us, in which I've simply taken this tree node star answer equals to new node, just a dummy pointer. As first value is 0, so that's why at the end I'm simply returning the answers right. So the first thing which I've done is, as I've taken this particular, we are taking two tree nodes, and this particular node I'm simply assigning answer towards it. So whatsoever answer would be there in this particular current, that would be simply easily able to be returned by this answer. Basically filling up this answer with this current node's value. So now the thing is, we'll simply call this function where I've passed this root, and now if node is present, that basically if node is not equals to null, then first I'll go towards the left subtree, then make the nodes left equals to null pointer, and then I'll simply assign current right equals node, and then simply move current ahead, and then I'll go towards the right subtree. That's all I would be doing, and simply populating our current pointer which is being there. And after all this which is being returned, our current node would be simply populated, and it would be simply having the answer which is required. And now, as all the filling was being done as per the answer node, so now our answer node is completely ready to be returned, and then at the end we'll simply return answer which is pointing towards the right, because it will simply become a right skewed thing. So this was all for this particular question, and the time complexity, that is the order of n simply represent the number of nodes, and the space complexity is again order of n, and this order of n space complexity is simply because of the recursive stack which is there. Although we are not using any extra space, but if we want to consider for the recursive stack, then yes, it is order of n. So this was all for this particular question. If you have any doubt, you could comment. Please do like and subscribe to the channel and share the video if you like it. Thank you.